Hello, everybody, and welcome to our EclipseCon 2021 talk, Unleash the Power of Eclipse Technologies, the Benefits of Modernizing Your Project. Let me introduce myself. My name is Dirk Faut. I'm a research engineer at Bosch, and I'm an Eclipse committer in the Eclipse platform and also for the Nebula NetTable project. And with me is my colleague, Harald Makamul.
Hello. I'm also working for Bosch in the Bosch research division, and we did together the work in APPAMC, and we will talk about our progress in modernizing this application. So, what will you hear today? A short motivation, then I will talk about general improvements we did regarding our project structure and also the Eclipse infrastructure we use. Then Dirk will continue with some issues and solutions we used to make this better. That is especially the use of Eclipse technologies. And in the end, I will show some of the benefits we already gained in using these approaches in our project. So our situation was at the beginning that we had a code base with many contributions from different participants. It was a publicly funded project. And in the end, we had a quite diverse number of plugins and different styles of programming, a monolithic build, and multiple dependencies. So our goals were to increase maintainability mainly, to make it easier for us to deal with that. And of course, we wanted to make it simpler for others to contribute to that project. And of course, also to make it easy to use our project in different contexts. So let's start with some general ideas. Dependencies, libraries. When it comes to libraries, it's always a question. You should use libraries, of course, that is true. And it's a recommendation of a very good and famous book. And on the other hand, you have dependency hell. So a lot of dependencies will make it difficult to handle. You will have version conflicts, you have larger runtime environments, and it might be difficult to use it in another context. So the question was, is it possible to limit the dependencies to the really required ones? And to give you an impression, we started to think about things like, if we deal with model files, for example, and folders, what is the right level for this specific component? Can we use the Java level, so Java I/O with the file object? Should we use Eclipse and the resources where you have another level of abstraction, like folders, projects, or on EMF level, resources and resource sets for a combination of them? So it's up to you to decide what is the right level. And if possible, I would recommend not to mix it too often, because it's always switch between the context in some sense. The other important thing in an Eclipse environment is, or it was for us at least, is the workspace really required and the workspace handling. So we tried to reduce the dependencies of our central modeling plugin, and we were able to reduce the dependencies, and we are now independent of workspace. And in another use case where a service uses the model plugin to load the model, and then we generate some code out of it, we could really improve the deployment size. And we had a faster startup, because in the old case, we had to deploy an Eclipse application, a headless one, and we had to unpack it, we had to start it, workspace was created, and so on. And in the new case, we have a jar that is executable, that is portable, compared to the platform-dependent Eclipse situation. So it was really an improvement for us to use this new approach. Now regarding the Eclipse infrastructure, as I said, we had a monolithic build before, and we now try to create components. These components also are reflected in different repositories. So for example, migration is a repository. We have a build, a Jenkins build that creates a P2 repo and a headless jar. So that can be used independently. Then we have the platform, and that of course consumes the result of migration, because migration can also be started from a menu entry. And we have, for example, transformation that again produces a P2 repo and a headless one. And in the middle case, it was a product in an archive file so that you can create it directly on your local machine. What we did recently is we also published to Maven Central to make it easier to consume. So some examples here. If you create P2 repos, it's your choice how to organize the whole thing in a download area of Eclipse. That is the recommended way. So you can decide how you want to use the folder structure. And in our case, we always provide the download side and the headless part with a README file, how to use it. The second thing, Maven Central. So we only published elements that are generally useful from our point of view. So currently no UI plugins, but model handling, migration, validation, and some utilities. And because we use a pomless Maven Tycho system, it was easy to deploy it via Maven deploy. And to be good Maven Central citizens, we also provide the dependencies in the POM file. That is double work, but it has some advantages if someone consumes it on Maven Central, so dependencies are clear on that level. You will see also some of the links here. Very often it's related to the wiki of Eclipse or some other blogs. So one last thing from me, that was we also tried to improve code quality and installed some Sonar Cloud projects for our main components. And we really were able to track code smells and bugs and things like that. There are still some open issues because test projects are also mentioned here as bugs, or we had to review some hotspots. But in general, we were able to improve it quite a lot. And coverage is, of course, also included. Now, I will hand over to Dirk for the general topics of Eclipse technology.
All right, so let's move on with what we have done in using Eclipse technologies to improve. The topics that we have here are modular product updates. We improved the startup performance, mainly by dropping plugin activators. We introduced builds with pomless Tycho. We migrated from extension points to declarative services. And we migrated from Eclipse 3 to Eclipse 4 in several places. So let's start with the modular product updates topic. So what we have is a feature-based product. Because a feature-based product is easier in the definition, because we just define the feature that we use or the features that we use. We don't need to configure every single plugin that we want to integrate. And we want to get modular updates. But we realized in an older version, in the previous platform, that when we tried to do a modular update, we were not able to do this because we misconfigured the product. We only have one root feature. And if we then select a single feature out of it, we see we cannot uninstall that single feature or update that single feature because it's part of APPAMC tool platform. So actually, we were not able to do modular updates. What we did is we double-checked which features are independent and configured them as root features. I'm not sure how many people of you know the term root feature. It was new for us when we did the migration. And when we learned about it and understood what the root feature is, we configured it everywhere it should be. And since newer versions of Eclipse, well, at least I think that feature exists for a long time, but it did not in the past. You can toggle the install mode from root feature to sub feature via a button that is marked here. Or you can directly change it via the properties dialog. With this, we now have the modular updates. Now the installation dialog looks like this. We have all the separate features that we can update solely. And yeah, you see at the bottom now we can update the converters and or uninstall even the converters from the product. The next one is we looked at the startup performance by removing activators. That's a topic that exists for several years in Eclipse Platform itself. So there's a lot of work done to remove the activators. Why are there actually so many activators? Because the Eclipse PDE tooling created an activator by default. So users created activator without even knowing that they created them or why they need them. The problem with such an activator is it's executed in the UI thread. So it's executed in the UI thread when the bundle is started by the framework. So if you do heavy load in an activator, you're delaying your application startup. But typically, the activator in an Eclipse plugin is not used as it's intended to be. It is used as a single point of feature access. For example, people use the activator to retrieve the bundle ID, or they use it to perform logging facilities. They use it to access preferences or resources, or even dialog settings. Over the past years, there are a lot of replacements in the Eclipse platform that help you to get rid of these activator patterns. That is, for example, you can use the framework util from the OSGI's bundles. You can use common logging facilities or functionalities. There is, for example, platform get log, which is what's actually even used when you use the activator approach. For accessing preferences, there are the scopes that you can use. There's an article by Lars Vogel that explains that. Same for resources. There is the local resource manager that you should use to handle resources. There's also a good article by Lars Vogel. And since 4.18, which is the 2020-12 release of Eclipse, there's also a platform UI get dialog settings provider function. I have linked the ticket to this, which was the last one for us to get rid in the activator section. So you can get rid of all the activators if you only use these features. What is an activator actually used for? It's used to deal with required actions on startup. If you need this, you can also use an OSGI declarative service called immediate component. That's also immediately executed on start of the bundle. What you can also do is use an event handler for the app startup complete event. That would be triggered once the application is ramped up. So the startup is complete from the Eclipse application perspective, from the platform perspective, and then you can do additional stuff. But we also found out there are reasons for activators, and well, we didn't force removing everything. If it's not needed to remove it. So there are actions that need to be executed in the UI thread on startup when the bundle is started. And one example we found are the series viewpoint registrations. So the design of the series viewpoint registrations is that they need to be loaded once the bundle is started. So that's actually, there's a reason for it. So we did not force removing it. Pomless Tycho. With pomless Tycho, if you're not aware, the idea is that you don't need POM.XML files for plugins, features, and test projects. That's quite a lot for huge Eclipse projects already. But since 1.5, you also don't need POM.XML files for target definitions, products, and update sites. And no connector POM.XML files if you have a structured environment like on the right side shown. For big Eclipse projects, you typically have this folder structure, and if you have one parent POM, you would need the connector POMs to go up. These are also not needed anymore since 1.5. when we introduced this real pomless Tycho with the newest version, we reduced the number of POM.xml files to a real minimum. Actually, we only have, in most cases, the root POM.xml, the parent POM.xml file. And for some special topics, like, for example, the Maven deployment, the Maven central deployment, or if we create help sections and so on, there we need these specialized POM.xml files, but typically we don't have them anymore. And we reduce the effort for version updates in the build drastically. So we now are able to do a version update with a single command line execution. I have also written 2 blog posts about this. So one is about the pomless Tycho builds for structured environments, and one is about the pomless Tycho enhanced. Both together will lead you to the current situation in our builds. The next topic is one of my personal favorites. If you know me, you probably can now laugh, because declarative services are one of my favorites. So what are extension points? Extension points are kind of a service approach in Eclipse. You have a definition via XML and XML schema, but by definition, it's a one-to-many relation design. So one plugin defines an extension, and then an extension point, and then other plugins can contribute to this plugin. So this is the design idea behind an extension point. They are consumed programmatically using the extension registry via an ID. So there is no type safety. If someone is contributing there with a wrong type in some way, well, it fails at runtime. And we don't have dynamics at runtime, so you cannot publish or remove extension points dynamically. Well, probably you can if you're working directly on the extension registry, but that's not the intention. And also a downside is that extension points are Equinox only. So they are designed for Equinox, not for other OSGI runtimes. Declarative services, on the other hand, well, they are also defined via XML, but the XML can be generated by tooling. So that's a DS annotation tooling. OSGI services are designed to have a many-to-many relation. So you can publish services and then consume them from anywhere. They are consumed via injection, so they are type safe. And dynamics are supported at runtime by default. So if a bundle is started, new services come up. If you stop it, the services go. So there is a dynamic principle by design, and it's OSGI standard. So if you want to deploy a small OSGI application on another runtime, well, it will simply work. Then we have the Eclipse 3 to Eclipse 4 migration. What we did is we migrated the UI contributions from an Eclipse 3-based mechanism to Eclipse 4. So we contribute the model fragments via fragment E4XMI file. This includes commands, handlers, and menu contributions. And we migrated the view parts to be parts. This helped us to use the injection annotations, for example, the add service annotation, which helps us to get OSGI services injected into the Eclipse layer. We also migrate core expressions to imperative expressions with the add evaluate, which means we migrated the plugin XML structure for a core expression to a programmatic expression, which reduced a lot of load. And we added context values via model add-ons, for example, which version of the MLThea model is currently in use. We also use the event bus in several places, which is also a core feature in Eclipse 4. What we achieved with this is we reduced the code bloat. We now participate in the E4 programming model with the injections. We use injections even for OSGI services, which is a big benefit when you move to OSGI services. And we have a loose coupling between modules. So the migration is now not tightly coupled to the platform anymore. For example, the migration of the service provider, well, you take the declarative service, you take the extension point implementation, add the add component annotation to the implementation, delete the plugin XML, and you create component references via add reference. The consumer on the other side, well, this was the old consumer, so we extend or implement the I handler or abstract handler in E3, and then we have this method signature with the execute and throws execution exception and so on, and you need to retrieve everything from the event. And then you need to operate on the extension registry to get everything from it. So that's a lot of code, and code that can fail. As you can see, this type instance of type. Yeah. Okay. You can see we're casting. Sorry, type casting. Too much talking today. Sorry. Okay. So the service consumer on with declarative services and E4 is actually looking like this. You have a Pojo class named migration handler, and we get injected the migration processor, which is our service, and we have the APPAMC model version, which is the version that's supported by the model editor. We simply get it injected. There is no searching, no programmatic stuff needed to get here. For the events, what we wanted to introduce is that we trigger a model migration from the model editor directly. So we have this event listener, and we have the event publisher. So we can trigger, when we open a file, we can directly trigger this event in case we realize that the file needs to be migrated. And now migration and the platform are loosely coupled. We have this same loose coupling also for triggering selections in the model editor from anywhere. So we have in the editor this event listener, and wherever, for example, the visualization part, you're clicking an element, we can send this event, which then triggers selecting an element in the model editor. So now I'm giving back to Harold, who is talking about the benefits we achieved with some examples in APPAMC.
Okay, we now go to some practical examples. We will show how we used the migration framework, the cloud services, validation framework, and visualization. You want to do that?
Okay. I can also start with the first two topics because they are my favorites. Okay, sorry. Okay, what we did, we created command line applications out of our Eclipse plugins. So we created small Equinox headless applications, even by using Maven Tycho. These headless applications have about 5 megabytes. When they're in Equinox, they have a folder structure and a native executable. But from there, we even created executable jars using the BND Maven plugins. They have about 4.5 megabytes, and they are single executable jars. So they are really easy to share with others. There's my blog post about this topic, so you can have a read about the details. The other thing is the cloud services, which we also achieved via all these refactorings. So we create cloud services, REST-based services using OSGI specifications, namely HTTP whiteboard and the JAX-RS whiteboard. We extracted APPAMC function services like validation and migration or transformation as services and deployed them into a cloud infrastructure. And now we're able to chain all these services without an installed platform. That means we can take an MLTR model from any version, and it's automatically migrated, then placed to the validation, transformation, simulation, visualization after that. So we can really see how would be the effect of a model change directly after a transformation and simulation. So a microservice approach. This was done in the Panorama project scope. And I have also written a blog post about how to access OSGI services via that interface, which is using the HTTP whiteboard, and also a blog post that is using the OSGI JAX-RS whiteboard. So you can also get the details online and have a read. Now, Harold, it's your turn.
Thank you. So now we come back to the Eclipse platform more. So we have 3 examples here how we use the extensions we created, the dynamic services and the E4 contributions. The first thing is an independent validation framework for our models. The basic idea is we have validations that implement a validation for a specific model class, and we have profiles that group these validations, and you can also have this in a hierarchical order, so multiple profiles can be combined to one bigger profile. The idea is details are specified with Java annotations, plain Java, and the top level objects or profiles are OSGI components. How does it look like for a developer now who want to contribute? In general, you can provide these top-level elements with a component annotation. You can have profiles with some names, and you can specify how validations should be used in that context and how the severity of this is. And in the end, you have to program, of course, the validation itself. So you will get the object and you can perform some validations on it and provide some diagnostics as a result. In the user interface, this all is used and it looks like the image on the right side. So the component annotation leads to top-level elements in this tree. The names are reused as items or item names here. And of course, also the additional information about checks and the ID is provided here. And next one is a visualization framework, similar idea. So we wanted to have the possibility to select an element in the editor and then provide some visualization for this specific element. We had 2 goals. We wanted to make easy to contribute, and we wanted to make easy to implement this. And what you see here is a complete definition of one of these visualizations. It only displays the name of the element, but it's just for demonstration purposes. And if you see it in context, this will create an entry in a specific view that is called visualizations here. And if you provide a visualization for a specific element, then your visualization will appear in this list of possibilities if someone selects an element. Again, names and description are reused, so this is very easy to use. And a third one, similar again, but that's the purpose of it. We have a component annotation that now provides editor actions. So you can define specific actions you want to do on one type of object. And you can see here that will lead to a menu contribution. And therefore, all the information is used, the menu structure, the description, and the user only has to do the manipulation of the model, and all the other things are done by the framework. So for example, the command structure of the editor, so that you can undo the action. So already the conclusion. From our point of view, we reached the main goals we had. So our main achievements are really a smaller code base. It's easier to maintain all this. We have simplified contribution and adoption of our system really a lot. And it's easier to consume via Maven and plain Java things. And best thing, it doesn't have to be a big step and you have to do all of this. You can have independent steps and apply gradually parts of these modifications we did. So that's it from our point of view. Thank you, and don't forget to vote.